Hi guys, welcome to lesson 5.1, rate of change and slope. Our objectives for today are that I can find the rates of change from tables and that I can find slope. So rate of change is something that you should probably be familiar with from 7th grade. You may have talked about, or when you talked about unit rates and rates, but the rate of change, our formal definition, is the change in our dependent variable over the change in our independent variable. And there are multiple ways that we can reference this. We can call it slope, which is the angle of the line. And the way we find that is the vertical change over horizontal change, which can also be represented as the rise or fall over the run, or the change in y over the change in x. That little triangle there is the Greek letter delta, and delta means the change. So delta y over delta x, change in y over change in x. So let's take a look. Our essential understanding, we can use ratios to show the relationship between changing quantities, such as vertical and horizontal change. Rate of change shows the relationship between changing quantities when one quantity depends on the other. Shows, not shoes. All right. So if we slide our page up and we take a look at problem number 1, finding the rate of change using a table. Our first example there, we have numbers of photos printed and the cost of the photos in dollars. So to use a table, let's just look from one line to the next. What is happening to each of our values? So on the number of photos printed column, we are adding 10 for each of our increases. So we just find that first difference there. This is called the first difference. All right, our total cost of the photos is increasing by, it looks like, $2 each time. So we're adding 2, and adding 2. So our dependent variable is always going to be our right column. Our independent variable is always on the left. So if it's dependent over independent, we have 2 over 10, which can reduce to 1/5. Now, I'm not going to be picky if you want to use decimals or fractions. I will just say that when it comes to graphing these problems, writing it as a fraction does make things a little nicer for us. So when we're going that route, I do recommend writing as fractions. And especially if they're repeating decimals, I would definitely leave it as a fraction. So anything that's thirds, sixths, ninths, those kind of things, you definitely want to leave those as fractions. All right, so letter B asks us, if we use non-consecutive rows, will we get the same rate of change? So I just did an example of if we went from the first row, the 10-2 row, and down to the 30-60 or 36 row, we're going to be adding. We'll be going up 4, so if we go down 2 rows on our table, we'll be adding 4, and we'll be adding 20 to our number of photos, which still is going to reduce to 1/5. So Mr. Wolf is drawing in this example on our page here. So we have +4 and +20. So as long as we have a linear relationship, no matter which lines we choose, we will still get the same rate of change. All right, letter C, we've got the table showing the elevation of a hang glider over time. Is the rate of change constant, and what is that rate of change? So our time, it looks like we're increasing by 1 minute each time, or each line. All right, and our elevation, we are subtracting, so 360 minus 325, we're going down 35 feet. So the way we would write that as a ratio is -35 over 1, which is just -35. The hang glider is decreasing 35 feet per minute. All right. Letter D, let's take a look at what we're doing here. So for our number of lawns, we're increasing by 2 each time, it looks like. So we added 2, added 2, added 2. For the number of dollars earned, we are increasing by 17. So when we write our ratio, we have 17 over 2, which we could just leave as that fraction. If you want to write that as a decimal, it would be 8.5 or 8 1/2. Okay. I will say we will not ask you to give us mixed numbers. We'll either be looking for, most likely, the decimal or the improper fraction. You do not need to give us mixed numbers at all, though. Okay. So why don't you guys try the problems on the next page at the top, letters A and B, and we will go over it. So letter A, we have number of raffle tickets, and it looks like our first row we are adding 2 each time. Our second to third rows we're adding 4, and our third to fourth rows we're adding 2. Now if we look at our total cost of raffle tickets, if we go from 1 to 2, that's an addition of 1. If we're going from 2 to 4, we're adding 2, and from 4 to 5, we're adding 1 again. So you want to just pick one of those ratios, and we'll go with it. So if we did just that first line, which is adding 1 over 2, 1 over 2 is 1/2. But if you were to look at the next line, 2 over 4 is still going to reduce to 1/2. So it's going to be the same no matter which line you pick. Just because these changes are not the same doesn't mean they have different slopes. All right. So letter B, the X column is increasing by 2 every single time. The Y column is decreasing by 3 every time. So we have -3 over 2, which we can just leave like that. Or if you want to write it as a decimal, it is -1.5. All right, now moving on to problem number 2, finding the slope using a graph. So this method, we're going to find our rise and run a little bit differently. So we're going to use a counting method. And we're going to count how many hops it takes to go from one place to the next. So I always start with my rise. So I'm going up 1, 2 hops to get to the same level as from my one point to my next. And now how many do I need to go to the right? We're going to go 1, 2, 3, 4, 5. So we went up 2 and to the right 5. So our ratio is 2/5. All right, for letter B, it looks like we're decreasing. So we're going down 1, 2 hops, -2. And we're going to the right 1, 2, 3, 4, 5, 6. So we have -2 over 6. And that can reduce to -1/3. Okay. All right. Let's take a look at problems C and D, and we're going to draw in some points because there aren't any provided for us already. So the points we're looking for are ones that are crossing the corners of our grid lines very nicely. So I have one at -1, 2 there, and I have a point at 3, +3. We don't need those coordinates right now, but we're going to just count our hops. So we're going to go up 1, and we're going to go to the right 1, 2, 3, 4. So our slope is going to be 1 over 4. Okay. Letter D, we're going to pick a couple points again that are good points to work with. All right, now we are going down by 1, 2, 3. So -3 to the right 1, 2, 3, 4, 5, 6. -3 over 6. Now, if you'll notice, that can be reduced to -1/2.
-1/2.
-1/2. which, if we followed that pattern down of -1/2, if we went down 1 and over 2, oh look, there's another point we could have used. Down 1 over 2, there's another point that we could have used. So this is a way of finding multiple points along our line. We could have picked any one of those points in order to come up with our slope. I just picked the two that were a little further apart. All right, so I want you guys to try letters A and B on your own, and then we will go over the answers. All right, so letter A, we are going up, and we need to count our hops.
Oh.
We're going up 1, 2, 3, 4. And we are going to the left, or to the right. 1, 2, 3, 4, 5, 6. All right, so we have 4 over 6, which can be reduced to 2/3. All right, letter B, we're going to start. We're going up 1, 2, 3, 4, 5, 6. Or actually, we're going down 6. So we have -6. And we're going to go to the right 1, 2, 3, 4. So we have -6 over 4, which we can simplify to be -3 over 2. All right. So next up, we have finding the slope using 2 points. And this is where we're going to use our change in y over change in x equation. So Mr. Wolf is writing this equation in. y2 minus y1 is equal to x2 minus x1. And he's marking those in on our ordered pairs. So one ordered pair is going to be our number 1s, and our second ordered pair is our 2s. So y2, which is 1, minus y1, which is 3, over x2, which is 4, minus x1, which is 1. So 1 minus 3 is -2. 4 minus 1 is 3. And that is our answer. Our slope is -2/3. And you'll see Mr. Wolf has been writing m equals. If you don't remember from last year, we use m to represent slope in all of our equations in our generic forms. So m is slope. So what is the slope of the line through the points 4, 3, and 9, 2? You're going to do the same thing, x2 or y2 minus y1 over x2 minus x1. So we have 2 minus 3 over 9 minus 4. Now one thing I do want to point out to make sure, when you have these points, your ordered pairs should be above one another. So we have the point 4, 3. 4 and 3 are above each other. And we have the point 2, 9. And 2 and 9 are above each other. So your ordered pairs should be in the same position in your equation. All right, so 2 minus 3 is -1. 9 minus 4 is 5, and that's our slope. Okay. Letter C, what is the slope of the line through the point -3, 2 and 1, 5? So these are where you need to start being careful with your negative signs and our negative rules. So y2 is 5 minus y1 is 2 over 1 minus -3. So make sure we are adding. So we have 5 minus 2 is 3. 1 minus -3 is a +4, so our slope is 3/4. Letter D, what is the slope of the through the line? -3, -9, and 7, -4. So we're labeling x1, y1, x2, y2. So -4 minus negative 9 over 7 minus negative 3. So negative 4 minus a negative 9, we're adding 9, so that's going to be negative 5, or positive 5. Down below, 7 plus 3, so we have negative 4 plus 9 is 5. 7 plus 3 is 10, and we can reduce that fraction to 1/2.
Okay. Okay, so we are going to move on and we're going to try A. This is going over the same thing. So I always make sure that I mark each one. Oops, that's a Y. Just to be sure I'm plugging in the right numbers. A lot of times I switch those up. And remember, throughout all of this, we're going to stick with the y2 minus y1 over x2 minus x1. You guys are going to be using that a lot from now on. So y2 is our 2 minus y1, which is 6. x2 is 3, and x1 is 1. So 2 minus 6 is negative 4. 3 minus 1 is 2. And then negative 4 over 2, that is also equal to negative 2. And that is going to be our slope for that one. Moving on to the next one. Again, always label. Trust me, it comes in handy. So, same setup. y2 is going to be 6 minus y1, which is 2, all over x2, which is 9, minus x1, which is 8. So we have 6 minus 2, which is 4. 9 minus 8 is 1. 4 over 1, that's just going to be equal to 4. So our slope is going to be 4 for that one. All right, moving on to letter C. y2 in this one is 5 minus y1, which is 1. x2, negative 3, minus x1, which again is 3. So for this one, 5 minus 1 is 4 over negative 3 minus 3, which is going to be a negative 6. That can be reduced, and that means our slope is going to be negative 2/3. All right, on to our final one. Our y2 for this one is going to be negative 4. y1 is 7, so negative 4 minus 7. x2 is going to be 2. x1 is 5, so it's 2 minus 5. So negative 4 minus 7 is negative 11. 2 minus 5 is a negative 3. And this one, we got to remember, we've got two negatives both in the numerator and the denominator. Those are going to cancel each other. So that means our slope is actually going to be a positive 11 over 3.
Now, Mr. Wolf, what if I pick the points in the other order? What if I decided that I'm going to use x1 minus x2 instead of x2 minus x1? Am I going to get the same answer?
Well, let's try it. You said x2 minus x1?
Yeah, so let's flip them around. Let's do y2 minus y1 over x2 minus x1.
Oh, okay. Or wait.
Or x1 minus... Yeah. We're going to just flip the order of our two ordered pairs because, sometimes we do that.
Just to see.
Yeah. So we'll go with
okay.
7 minus negative 4.
Mm-hmm. So this will be 7 minus negative 4.
Over 5 minus 2.
Minus 2.
Equals. So you can see all we've done is we've switched which order we put them in. So 7 minus -4, that's going to be plus 4, so it's going to be 11, over 5 minus 2 is 3. Hey, look, that's the same. All right, so this is one thing, guys. If you're looking and you're seeing you've got a bunch of negative signs in one of yours, you could choose which order you want to go in. I'm not going to be picky that you have to go the first one listed being x1 and the second one listed is x2. You can choose whichever order you want if it'll make it easier for you to deal with negative signs. All right. Okay, so let's go on to the next page. Our last section, which is finding the slope of horizontal and vertical lines. So for letter A, what are we doing? I'm just going to pick 2 random points on there. Pick any 2 random points.
Let's go 1, 2, 3, 4, 5. Let's go.
So we have a point at
6.
-6.
Positive 6.
-6, 6. Okay.
Yeah. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah.
Right.
Negative, positive.
So we've got a point at -6, 6.
And then we'll do 1, 2. 1, 2, 3, 4, 5, 6.
All right. So let's write those coordinates in. So we've got -6, 6. And we have 2, 6. And now we find our slope. So we can do the equation if we want to. So 6 minus 6 over 2 minus -6. So we have 0 over 8. Anything 0 divided by anything is just 0. And we can see this. What is my rise in this? My rise is 0. I didn't go up or down at all. And I went to the right 8. So it'd be 0 over 8, which is 0. All right, now let's take a look at letter B here. So let's just pick 2 random points on that vertical line.
1, 2, 3. Let's go 2.
All right, so we have a point at 3, 2.
And we'll do 3. Let's just do the opposite. Let's do
right.
-2.
So we got 3, 2, and 3, -2. So let's do our rise over run. So we do y2 minus y1 over x2 minus x1. So we have -2 minus 2 over 3 minus 3. So we get -4 over 0, which is undefined. Do not say 0. If you say 0, we will throw things at you. It is undefined. You must write that word undefined because you cannot find that slope. It is undefined. We cannot divide by 0. All right. So letter C, if we take a look at the ordered pairs, we have 1023 and 106, 2 good dates. So we have 6 minus 23 over 10 minus 10. And that equals -17 over 0, which is 0.
Ooh, wouldn't that be?
Oh, sorry, that is undefined. Yeah. So remember, write the word undefined. We cannot divide by 0. All right, letter D. We're going to do the same thing. We have a couple points here. x2, y2, x1, y1. So we're going to do 8 minus 8 over 6 minus 3. 8 minus 8 is 0. 6 minus 3 is 3. 0 divided by 3 is 0. All right, so if you look at our little Mr. Slope guy here, and we can see a little bit of a reference of how to take a look at these lines. So if the line is going up from left to right, it's a positive slope. If it's going down from left to right, it's a negative slope. If it's vertical, it's undefined. Makes a nose. And if it's a horizontal line, it's 0, his dimples. So might be something to help you guys remember slope. All right, so make sure you guys are filling out your level of understanding for this problem. and write down any questions you may have over the lesson and write down the summary of what you learned. See you all in class.